Hey guys, right in this video, I'll show you the use of distributed load and how to assign this in various examples in ETABS. So the first case is, let's create a new project. As I'm not going to design anything, I don't want to really care what code you are picking. As I'm from India, I would like to pick up metric SI for the system of units and hit OK. I'll be analyzing only beam structures, so these numbers really depend on the problem that you're having. So right in my case, I really don't want this much stories and this much grid spacing, so let it be like 2 meters and all. No, let it be like 5 meters. Okay, that really doesn't matter. Alright, so this is a quite good screen right here. The first thing that I would like to do here is I never like this much lighter color, so picking up the black background. Alright, that's great, and that's not entertainable. Before starting everything, I'd like to draw a beam right in the base. Okay. So getting to here, quick draw beam columns, and I like to pick up the base. Alright, so this is the beam right here. I like to explain the use of distributed load section right here. So first let's activate that option here. The first point that we want to care is the type of load patterns, whether you're assigning the particular load into pattern dead or pattern live. Most probably 99%. In the most probable case, we'll never have a distributed load in the live section, so I'm not going to change this value. We're having forces and moments right here, and almost all the forces exist right in gravity direction. Okay, if that's not gravity, projected axis is already explained in my other video, so you can check out that video. I'm not going to provide any sort of link. If you have time, you scroll all of my videos and watch. There is something explained instead, so you can watch that stuff. Alright, gravity is there, global X and global Y, which you can understand that is the X axis shown right here and the Y axis shown right here. And next, let's see how the local axis works. So in order to get the local axis or to view the local axis, let's get into view, and I like to pick up the set display options here. Getting to object assignments, and right in here we are having the local axis is right here. So you're ending up with 3 different colors, which is red, green and blue. I'll tell you what and all are these loads here. So right now I don't have a pen, so the red or the local 1 denote local x-axis, and green denote local 2 or local y-axis, and this is blue axis, which denote local 3 or local z-axis. Local x, local y and local z corresponds to local 1, 2, 3. That again corresponds to RGB. Okay, you can match up with those colors to understand what load comes where. Okay, so that is the case. Right now I don't want this gravity. I am having a gust right now. Anyways, it doesn't matter. Alright, first you want to select the object, get into the distributed load section. Okay, the first point that I would like to tell you is the uniform load right here. We don't want to give any negative value to these numbers, so just a positive is enough. Positive in a gravity direction that indicate the load will be acting right in negative global z. So assign it. So right now you can see the load is right here. Alright, positive value indicate that is to the gravity direction, so understand that's the first point that you have to observe right from here. Alright, if you don't want to see or if you want to delete this load, you can hit the delete button, select the object and hit apply, so the load is deleted. Alright, we are having 2 options right here. The first one is replace and the second one is add to. Okay, right now we don't have any load. Okay, if I hit apply, so the 3 kilonewton is right away in here. Okay, now the option turns right into add to existing load. Okay, 3, if I hit 7, select the object and apply. So already there is a 3 kilonewton per meter axis on the beam. If I hit 7, so 3 plus 7 will show that is 10 kilonewton per meter. So the existing load will be right there, and the newer load will be added right into the newer load will be added right on top of those existing load. Whereas if we hit replace, the 10 will be deleted and the newer load will be added right into the structure. So that's the main difference. The first one shows whether you want to add to the selection set. The second one will delete from selection set and replace the load with the newer one. So that's the case. Alright, that's all about the uniform load section. Now we are having trapezoidal loads right here. Alright, the next point is we are having trapezoidal loads right here. Okay. In this case, if the load is trapezoidal, we are having relative. The distance can be set as relative or absolute. Right, in relative case, the length of the beam will be expressed as percentage, like right at the 0, which means that 0 indicates the start of the beam. Right at 0, the load value, if that is 1 kilonewton, you can enter 1 kilonewton per meter. Okay, right at L by 4, which comes to be 25% of the total length of the beam. If you don't know the length, you can go for relative method. Right at the 25% of L, we are having maybe 4 kilonewton per meter. If the load is right at center of the beam, we can go for 0.5, that's 50%. Maybe the load is 2 kilonewton, and right at maybe right at L by 80% of L, 4 by 5 L. If the load is 5, you can enter it like that. So you have to understand that if the case is relative, the length of the beam will be expressed as percentage. So really that follows here. So if I hit apply right now, if I didn't select it, that errors will pop up. So you can just hold on. I hit apply, and you can see that right at the starting of the beam, the load is 1 kilonewton. Right at L by 4, you're having the load is 4 kilonewton. You're seeing that the load is being interpolated linearly. Right at the L by 2, correct? Right at the center of the beam, you're having the load is 2 kilonewton, and right at 4 by 5 L, or 80% of the length, you're having maybe 5 kilonewton right here. Okay, the first thing that you have to understand from here is the load will be interpolated in between linearly. Okay, and the second thing that you have to understand is if this value is not 0, if you're maybe putting maybe 3 kilonewton right here, finally the load will be summed up. So if I hit maybe replace or add whatever, you can see that just observe 1, 4, 2, and 5 will be added with this number right here. So maybe the total load, final load will be, you can see that is 4. 4 is what? 1 plus 3 is 4. So do not mix up these two loads together, either if you're providing trapezoidal load. So the point that you have to understand right from here is if you're providing trapezoidal load, do not provide any uniform loads right here. Let it be 0, and vice versa. If you're providing any sort of uniform load, do not provide anything right in here. Okay, so that's the simple case that you have to understand right from here. Okay, that's the first case. And now if you're having more than 4 loads, example, I can show you that this is the asset right here, and maybe I'm having a load is right here, 2, this is 1, this is 2, well this is again 1, and this is again 2, and this is again 1, and this is again 2. Okay, this could be like 10%, this will be like 20%. Anyways, it really doesn't matter. I hope you understand this. 20% of L, and this could be like 30% of L. This could be like in 40% of L. I'm sorry, this will be like 50% of L, and this will be like 60% of L. Alright, we are going to simulate this type of load in ETABS. So the simple thing which you can understand is this is like 0.1, this is like 0.2, 0.3, 0.4, and you can enter this value 1, 2, 1, 2. Okay, select it, replace, and apply. Okay, so that's the first case. Now it's not over. From 50 and 60 we are having 2 more loads here. So if you are providing multiple loads, If you're providing loads greater than 4 numbers, hit the add button here and the load will be like 0.5, 0.6. Okay, that ends in 0.6, 60% of L. So you don't want to provide any of these numbers, so just hit 0, 0. Okay, the right in 60%, right in 50%, the load is 1, and right in 60% load is 2. Okay, then again you select the asset, hit add and apply. So you can say that 1 and 2 is already right here. So if there is no connection between these two numbers, really doesn't matter. So this is the first load. Now if we want to create more than 4 loads, so recreate the last load case right away from here. So that's 0.4 and 2. Now the load is 0.5 and 1 and 0.6 and 2. The last one, hit as 0, add it, and you can apply that. Okay, let's see what's happened. Let's see what happened. So that's how you will be applying these loads here. So right now all these loads are going in the uniform fashion. So right now you can see that transaction is perfect. So that's how you'll be applying more than 4 numbers of load right in this uniform distributed case. Alright, so now let's see what's the other option here. There's one more option here, so let's get into distributed. So relative is totally clear. Now let's see what is absolute. Right in absolute, you will be providing the total length of the beam in absolute quantity. If you know that the length of this 2 grid is 5 meter, yeah, that is 5 meter. So maybe right at the first, let me delete this. Okay, maybe right at the start of the beam the load is 2 kilonewton, right at 1 meter, so the distance will be calculated as the absolute quantity. So right at 1 meter the load will be 2, right at 2.5 meter from the start the load will be maybe 4, right at 3.5 meter from the start the load will be maybe 5. So that's how you'll be applying the loads as absolute quantities. So the important thing that you have to understand from this point is the distance will be measured in absolute quantity, as the length is not converted into percentage as you saw in the relative quantity. Alright, anyways, so now let's try to simulate some sort of load right in this software. So maybe the first load is the triangular load. Okay, maybe the span, I'm not changing the span, let it be 5 meter, and right at the start of the beam the load is 0, and right at the end of the beam again the load will be 0, and right at the center of the beam the load maybe it's like 5 kilonewton per meter. Okay, so let's try to simulate this type of load in ETABS. Okay, the first thing that you want to do here is, okay, if there's any load here, just delete that case. In the second case, we want to select the beam here. Okay, only we need 3 fields. Right at the start of the beam, okay, I like to turn it into relative quantity. Right at the start of the beam, the load is 0. Right at the center of the beam, the load is 5. So center denotes 50% of L. And right at the end of the beam, the load is 0. So we don't want any other field here. Now just hit apply. You can see that it's the triangular load in ETABS. Alright. So now let's try to create the second load here. Let it be the normal trapezoidal load right here. So this could be like the load value is 2 kilonewton per meter, and here it will be like 5 kilonewton per meter. See, this distance can be like 1 meter, and this distance can be like, I don't know, maybe 2 meter, and the total span is 5 meters, so this can be like 2 meter. Okay, so let's create this type of loads in ETABS. So you have to understand, so the first point, alright, the first point is right at 1 meter from the start the load is 2, right from, okay, stick on to absolute quantity, right at 1 meter from start the load is it 2? Right at 1 meter the load is 2. Okay, right at 3 meter from start, so you had to add these two numbers. Right from 3 meter the load is 5. Right from 3 meter the load is 5. Turn all the numbers into 0 and hit apply to see the load here. Okay, well, so that is the case here.